Welcome back to The Explainer. I am so glad you're joining us today because we are going to look at one of the absolute most fascinating technological power struggles happening right now. We're talking about how grassroots, decentralized networks are literally rising up to challenge the biggest corporate monopolies on the planet. Honestly, get ready to rethink basically everything you know about how artificial intelligence is powered.
So let's just start with a quick hypothetical. What if your idle computer could break a big tech monopoly? Seriously, I want you to imagine your unused hardware. Maybe it's that high-end gaming PC sitting in your bedroom right now. What if that machine was suddenly powering a global rebellion in the AI race? I know it sounds completely like science fiction, but it's happening right now, today, and the mechanics behind it are just brilliant.
Okay, let's dive right in. Here is the roadmap for our explainer today. First, we'll look at the big tech compute monopoly. Second, enter DePIN. Third, how the network operates. Fourth, why this changes everything. And lastly, number 5, real risks and limitations.
Starting with part 1, the big tech compute monopoly. Let's take a look at the sheer scale of power wielded by traditional cloud providers. The reality is, the current landscape is heavily centralized. Giants like Amazon Web Services, Microsoft Azure, and Google Cloud act as massive bottlenecks for the entire AI industry. Because they literally own the physical data centers, they have total control over the supply of processors and, obviously, the pricing. If you're an AI developer right now, you are dealing with incredibly high prices and agonizingly long waitlists just to rent the hardware you need to build your tools. The profits, the physical infrastructure, it's all entirely centralized in the hands of a very select few. And that leads us to this crucial point. Innovation is inherently restricted when a few massive corporations hold all the keys to processing power. This kind of severe centralization actively prevents smaller, independent researchers and scrappy startups from entering the market to build advanced AI. They simply can't afford the cover charge, and that ultimately stifles global innovation.
But, as they say, where there is a Goliath, a David inevitably emerges. Part 2. Enter DePIN. Let's look at the movement that's actively flipping the script on big tech.
DePIN stands for Decentralized Physical Infrastructure Networks. The easiest way to think about it is this. DePIN is to computer processing power what Airbnb is to real estate or Uber is to transportation. It's a distributed digital marketplace. It uses blockchain tech and crypto tokens to crowdsource real-world hardware, specifically GPUs, or graphics processing units, from independent providers all over the globe. So instead of building a massive multi-billion-dollar data center, DePIN just borrows the hardware that's already out there sitting idle in the world.
And the contrast here is literally night and day. Big tech hyperscalers force you into this closed-off, highly restrictive environment. It's expensive, you're put on wait lists, you have to go through all this corporate vetting, sign restrictive enterprise contracts, and everything sits in a centralized hub, which creates a single point of failure. DePIN networks, on the other hand, offer completely permissionless access. You can rent processing power instantly from a crowdsourced global supply. It's open, it's decentralized, and it completely bypasses all that corporate overhead.
Which brings us to part 3, how the network operates. Let's look under the hood. How does this actually work to connect an idle PC to an AI startup halfway across the globe?
Under the hood, this whole thing builds across 5 mechanical phases. First up, supply aggregation. Software clients pull together all this independent hardware into a single collective. Next is workload distribution. The network takes complex AI tasks, slices them into bite-sized pieces using containerization software like Docker, and sends those pieces across the network. Step 3 is automated verification. Step 4 is token incentives, which rewards the hardware hosts. And lastly, direct settlement, where payments are automatically sent out to the providers.
Now, you're probably thinking, wait a second, if I'm sending my sensitive AI calculations to some random gamer's computer, how on earth do I know they did the work right? Well, the answer lies in a brilliantly designed security feature. The underlying blockchain protocols run automated cryptographic checks. These mathematically prove that the untrusted hardware actually performed the calculations correctly and that it actually has the hardware specs it claims to have. These automated ledgers enforce all the rules, and they do it without needing a single human middleman.
To really wrap our heads around this ecosystem, let's look at the key players. First, you've got compute buyers. Picture a small AI startup. They have brilliant ideas but a super tight budget, and now they can finally run their models affordably. Then you have compute providers. Imagine a gamer earning passive crypto income by just letting the network use their graphics card while they sleep, or an independent data center monetizing their downtime. Finally, hardware aggregators are the platforms working behind the scenes, grouping all this diverse hardware together so it can tackle massive AI tasks seamlessly.
Moving right along to part 4, why this changes everything. Let's talk about the macroeconomic shifts and why this matters so much to the future of technology.
It really comes down to a very clear domino effect. Step 1. By crowdsourcing hardware, the network activates millions of idle processors worldwide that were previously just gathering digital dust. Step 2. Activating those dormant chips drastically increases the total global supply of computing power. Then, step 3, and as basic economics tells us, flooding the market with supply drives down the market price of running AI models. Then, step 4, lower prices empower those small startups, which effectively strips pricing power and market share away from big tech, diversifying who actually controls our global AI infrastructure.
And the financial impact of this is absolutely staggering. Because you're bypassing all that corporate overhead, you can rent processing power on a DePIN network for a fraction of the cost of traditional cloud services. Get this. For specific workloads, utilizing these decentralized networks can actually slash traditional cloud costs by over 50%. That is huge. That kind of cost reduction is literally the difference between a startup launching their product or running out of venture capital.
But let's do a quick reality check here. No technology is perfect. Part 5. Real risks and limitations. Let's impartially examine the hurdles this movement is facing today. When you look at the two models side by side, DePIN's limitations do become pretty clear. DePIN is highly efficient at inference specialization. That's the daily process of running existing AI models to answer your prompts. But when it comes to synchronous training, which is the initial creation of those massive foundational AI models, DePIN really struggles. It relies on the open internet, so it hits major wire bottlenecks, whereas centralized clouds have ultra-fast physical wire connections that absolutely excel at that. On the flip side, though, DePIN wins on geographic distribution because it runs much closer to local users instead of being restricted to specific corporate hubs. And beyond those training bottlenecks, there are some major practical risks we have to consider. First, performance variance. Independent home computers have wildly different internet speeds, making the network far less consistent than a polished data center. Then, sending sensitive data to untrusted computers creates real privacy risks if the encryption isn't absolutely perfect. On top of that, the user experience right now is pretty fragmented. Developers have to manage complicated cryptocurrency wallets just to get started. And finally, because hardware providers are paid in crypto, wild token volatility can easily disrupt the economic stability of the whole network.
So we've seen the incredible potential of crowdsourcing compute power. It can lower costs, it can break monopolies, but we've also seen its very serious limitations when it comes to synchronous training, complex user experiences, and volatile economics. All of which leaves us with the ultimate question. Will decentralized networks successfully democratize the future of artificial intelligence, or will the sheer convenience and massive infrastructure of big tech allow them to maintain their absolute chokehold? Thank you so much for exploring this fascinating topic with me today on The Explainer. Keep learning, keep questioning, and I will see you next time.